Thank you very much. I appreciate it. Can you all hear me? All right, super. So as was said, my name's Rod J.R. Duff. I'm the Executive Director for Business Development for all of the IMS Trimechanical companies. Over the last 25 years, IMS Trimechanical has positioned itself as a leader in the OEM equipment supply and services supply throughout the manufacturers of plastic products throughout North America. We have partnered with Bassano Extrusion Systems, as he mentioned, because we believe highly in their technology, in their mission, and in their dedication to our industry. And at the end of the presentation, I'll put on a couple of slides. This is about recycling. I'll put on a couple of slides on Bassano because they have technologies that relate directly to making a very good recycled product. So today we will talk about production waste from industrial plastics manufacturing. Recycled polymer is becoming more and more valuable in times of rising raw materials pricing, as well as increased environmental concerns. Nowadays, close to half of all plastic is ending up in a landfill or out in the wild. Only about 9% of plastic is recycled effectively. We are convinced that becoming more sustainable is necessary for the entire plastics industry. Becoming more sustainable can have huge advantages, though, in today's environment. This gives us the opportunity to adopt new technologies, start new collaborations, and make more profits. Fundamentally, plastics recycling is converting scrap into a valuable or usable product. There are numerous materials and plastics that can be recycled. Today we will discuss and present the recycling of PVC and polyolefins. The polymerization of olefins or alkalines is an efficient and low-cost reaction that yields polymers of high industrial value, such as polyethylene and polypropylene. These polyolefins have a variety of uses, such as the manufacture of plastic film, plastic bags, and plastic pipes. Pipe and profile. Polyolefins are relatively easy to recycle. Urban and industrial waste collection always consists of a mixture of three main plastic components: low-density polyethylene, high-density polyethylene, and polypropylene. These plastic fractions can be processed together for different applications within the injection molding, the blow molding, or the extrusion environments. PVC is one of the most used thermoplastics with respect to worldwide consumption. At a global level, PVC is consumed at about 35 million tons per year, and is only second to polyethylene as a volume leader in the plastics industry. Currently, PVC can be processed into a wide variety of short life products. In other words, PVC packaging for used in foods, cleansing materials, textiles, bottles, as well as medical devices. Also, PVC can be processed into long life products such as pipe, window frames, cable insulation, floor coverings, and roofing sheet. We know that both pre-consumer and post-consumer scrap can be recovered and transformed into new products. In mechanical recycling, the materials are ground up, remelted, and reprocessed. The high pressure, high temperature, and stresses undergone during those steps lead to changes in the polymer structure and properties. Polymers such as polyolefins do not have an infinite recycling and reuse capacity. This is because when plastics undergo high temperature or shearing during their process stage, thermomechanical degradation occurs. In fact, reprocessing recycled polyolefins is always accompanied with degradation, crystallization, and consequently there is processability issues. This is a result of the molecular chain succession, branching, and cross-linking. The degradation behavior decreases tensile strength and impact strength. In recycling processes, the behavior is inevitable, but the recycling product can still maintain quality and perform adequately. It is important to distinguish between the different types of plastics and their degradation. For example, HDPE, LDPE, and PP all belong to the group of polyolefins, but their degradation, I'm stuck on that word, degradation behavior during extrusion varies greatly. For example, in 100 consecutive extrusion cycles or uses, through a twin screw extruder using HDPE, a decrease in melt flow index was observed. Also, an increased extrusion torque and complex viscosity occurred within the first 30 cycles. However, LDPE, it was observed that for the first 40 cycles, the processability and long-term mechanical properties didn't change. Also, PVC material subject to degradation, got it, involving continuous changes in its morphological structures and properties during processing. This is due to shear stress. The fusion of plastic particles progressively changes the original particle in PVC, just like it does in POs or polyolefins. But in addition, PVC waste is also affected by dehydrochlorinization during its lifetime. All of these factors contribute to processing instability. Specifically, reprocessing HDPE and LDPE makes the material harder to process. I think we were talking about that earlier in one of the presentations, due to the decreased melt flow index, MFI, which significantly increases melt pressure, extrusion torque, and complex viscosity. Another challenge to PO recycling is that melt viscosity of the material increases considerably, making production processes more energy demanding. The higher complex viscosity makes recycled PE products difficult to extrude. So many challenges in recycling PO polyolefins, including degradation or loss of material properties or complex viscosity issues. But like anything else, there are solutions to these challenges. One solution, and the most popular solution, is melt blending. This is one of the most popular ways of mechanically recycling plastic waste. It refers to blending recycled plastics with similar types of virgin plastics or different type of recycled plastics during the process. Blending recycled plastics with virgin plastics of similar components not only can reduce cost, but the new blended plastics can maintain equal performance with the virgin plastic products. The melt blending technique is best when doing post-industrial scrap because of the basically due to the clear separation of the materials, and you also have less contamination in post-industrial scrap. And the low level of contamination present. Researchers mixed HDPE, LDPE, and PP with their individual virgin materials and tested their tensile strength. The results showed tensile strength of recycled plastics can effectively be improved by melt blending. Also for PVC, melt blending technique is the solution to the degradation problem. The formulation and percentage of virgin plastic and recycled material depends on the type of PVC though, and its former market use. Unlike PO that are similar and can be mixed, PVC compounds are different and cannot be mixed. Several tests were done, however, mixing PMMA and ABS with PVC to improve its quality and mechanical properties. Just like mixing different polyolefins within their family, these tests were also found to be very positive. With that said, it isn't sufficient just to mix recycled virgin plastics. PO and PVC scrap needs filler reinforcements as well. These can include natural fibers like wood, hemp, grain, sand is something I'm working on right now, and other inorganic fillers. They can improve morphological, mechanical, and thermal properties. Every project needs its own custom extruder and mix of fillers, additives, virgin, and recycled plastics. This is a subject that's starting to reach a little bit now into what's known as WPC, or wood plastic composites. We can talk about that afterwards. It's a whole subject in its own. For recycling PO waste, it can be possible to use a single screw extruder, twin screw extruders. It depends on the original waste and the specific project. When recycling PE in a single screw, the L over D, or the length over diameter, will need to be longer than in the normal single screw extruder. It is possible to process PVC on a single screw, but the twin screw extruder is much more directed towards that direction. One simple example is due to the PVC's rougher nature. So the wear and tear will be higher on the screw, which will be much more evident in a single screw extruder as you start to make inconsistent, as the screw accelerates in its wear, you'll begin to make inconsistent product. In the plastic recycling industry, the use of twin screw extruders is becoming more and more a winning solution to common processing issues and challenges. For this reason today, we are focused more on recycling with a twin screw extruder, and a typical twin screw extruder configuration for the plastic includes the material feeding system, the melting, and the mixing sections. Before recycled materials can be processed, the waste plastic must be gathered, cleaned, and then separated according to type. From this, waste is ground up and then can be delivered via conveying lines and feeders to the compounding process. In any recycling process, the material and waste plastics can be heterogeneous in size, in form, and in bulk density. Therefore, the correct choice of feeding technology is very important for ensuring the best results. An alternative to gravimetric feeders are volumetric feeders. They usually are cheaper but less precise. So for the recycling process, it's better to use gravimetric or loss and weight feeders. Single screw extruders are operated primarily using flood feeding, which are only suited for feeding bulk materials with consistent densities. When handling secondary raw materials, the bulk material characteristics can lead to irregularities in plastic flow, also known as surging. In contrast, twin screw extruders typically use gravimetric feeders, which are more precise and can react better to fluctuations in bulk density and material flow. There are various feeding technologies from vibratory to screw feed or weigh belt systems. The right feeder depends on the proper or right application. In compounding, the screw mixes and melts the polymer via shearing forces. The intense screw mixing and the possible use of low or high speeds up to 1,000 RPM makes the twin screw extruder, or TSE, a highly efficient and versatile mixing device. Screws are segmented and assembled on high torque shafts, and parameters are adjusted according to process, including additives like calcium carbonate or natural fibers. The mixing can be dispersive, it can be distributive, or it can be a balance of both. The TSE has various process control parameters like speed, feed rate, barrel or die temperatures, and vacuum levels. The TSE can help increase the melt flow index of polymer in a controlled way. One of the challenges of recycling waste material can be the residual moisture, monomers, oligomers, solvents, or decomposed materials. A reprocessing extruder line needs degassing and venting that are carried out during various stages of the extrusion process. In chemistry, an oligomer is a molecule that consists of a few similar or identical repeating units which are derived from copies of the smaller molecule, its monomer, just as a clarification. After the degassing phase, a vacuum pump pulls more volatiles, followed by a melt or gear pump, and then the material will pass through a screen changer. In many cases, the screen changer will come before the melt pump because the screen changer is there to remove any contamination in the plastic that a manufacturer can encounter with waste plastics before the pelletizing phase. Some processes require an ultra high quality in the end product. In this case, where low contamination is paramount, some manufacturers use a single screw in conjunction with a twin screw. A single screw extruder is used to melt and pump the feedstock through a screen changer prior to the fillers and additives with the twin screw extruder. This process allows the twins to mix with less energy used, saving on the need for more stabilizer. In fact, twins make better pellets. They are typically long and have segmented barrels, and are screws, and the screws are sectioned to match the barrel, so you can alternate sections of mixing and conveying of the material, venting and adding filler or other components. Twin screws work better with material displaying poor thermal capacity as well, resulting in advantages while processing polyolefin or PVC that degrade and become more unstable with multiple extrusion cycles. Twin screws have a lot of advantages when compared to single screw extruders for recycling. Beyond mixing capacity, including a better process flexibility. Twin screws can process multiple functions in series, such as melting, mixing, venting, and cooling, all in one extruder. The process parameters like time distribution, lower dispersion of shear rates, or higher convective heat transfer can be better adjusted in twin screws. Single screw extruders exhibit relatively low dispersion and devolatilization outputs. Depending upon the available raw material, this can lead to inadequate compound quality. So in the end, the best solution lies in using a twin screw extruder for compounding and recycling, except in the case where you have ultra high contamination and you've got a conjunction of two technologies. The recycling process are highly customizable and based on specific applications. From company to company, no two systems are exactly alike. I think we've all experienced that. You can literally go from line to line, same model, slight differences in the process. Recycling solutions require an OEM provider who has been proven over time and throughout the world. Bassano is a worldwide manufacturer who's been designing and producing extrusion lines for the plastics processing industry for over 75 years. Bassano has over 1,000 screw designs and new designs every day to meet the growing range of applications internationally. The plastic processing industry has traditionally been product-oriented, machine-oriented, and lacking in consistent company processes, engineering, and support services. At Bassano, we have found a solution to reverse that situation. Focusing on the customer is our mutual goal, because we believe that any project is only the beginning of a long journey. So just a couple of quick notes here. In 1999, they opened up the Brazil location to handle the Latin America, expand through Latin America, and the Bassano Brazil is now the leading extrusion supplier in the region on pure numbers of systems produced. In 2011, they opened up the India, a joint venture to serve that SEA market. One of the primary reasons we partnered with Bassano is that they do everything in-house, and that's critically important, and it's less and less happening in today's environment. From component drawing to line assembly, every step is managed internally by a highly skilled staff which undergoes continuous training. Part of that shows up in the screw. The screw is the core to the extrusion process. To obtain an optimal extrusion, the length of the plasticizing unit must be calibrated with the product that will be processed. Bassano specialists study every single case in detail to optimize the L/D ratio and allow the extruder to process different materials, even those that are difficult to gel. They have a range of extruders from compounding, pipe, medical products, tubing, profiles, and something that's becoming more and more the case, and something we get a lot involved in, is WPC or wood plastic composites. Bassanos are not only divided into product but also into type. Two product lines are the single screw extruders and the twin screw extruders. With the challenging that processing recycled polymers present, the Next Mover series is equipped with several patents. And this was something I wanted to get into you with about specifically here, which includes the multi-drive system, the smart energy system, and the digital extruder control to control every parameter of the production process. The multi-drive system for plastics processing is especially excellent for recycling. We talked about it a little bit earlier because you start to get into extremely difficult and high torque processes, and the patented multi-drive system is something that addresses those issues. The multi-drive transmission allows for the elimination of torsional stress on the control shafts and splits the stress on transmittal torque. The system of two intermeshing counter-rotating screw guarantees greater durability and optimal performance with any type of extrusion line. Distribution on 4 different points increases the life of the shafts and the gearbox, and improving the power of to the extruder with less energy consumed. So in other words, you're able to, with this system, you're able to produce more product with less energy consumed. Then there's the smart energy system. This is something I'm pretty fascinated with as well. The latest innovation from Bassano is the smart energy system that can be applied on both twin screw or single screw extruders. Bassano was the first to apply the principle of electromagnetic induction at an industrial level on extrusion machinery. With the smart energy system, the barrel is heated without contact by means of alternating electromagnetic field, a faster and more efficient method which guarantees top performance by significantly reducing component wear and energy savings of up to 35%. For recycling industry, offsetting energy costs becomes critically important. Then there's the Industry 4.0. Industry 4.0 goes a long way through deep into the Bassano history and is an important option that helps to automate highly customizable extruder solutions. In the area of big data, any device connected to the plastics production process will be able to produce invaluable data on its operation at any time, providing precise, real-time information on the progress of the extrusion process. This data will be collected, stored, and rationalized to improve, correct, and optimize production cycles. The control system implemented by Bassano consists of data collection platforms that interface with the operator and transmits information to all company applications. This solution allows processes to be simplified, making them more fluid, creating a true factory ecosystem. Introducing data collection software means transforming your company into a data-driven factory, i.e. a company that is data-driven and able to make decisions based on objective facts, not personal feelings. Digital technology is essential, but it is a strategic step and can bring a culture of data to all levels within the company. And with that, I thank you for your time. Any other questions? And I like that kind of question. Let's keep asking that kind of question. Most of Bassano's systems are applied according to application, and every system individually made. So how are we balancing the degassing of PVC in the process?
And last, the plastic cycle.
Any questions?